Circular Motion 2. Introduction. You have learned in Circular Motion 1 that you can have constant speed and still be accelerating all the time. Of course, if you were a roller coaster designer, you would need to be able to do the calculations to be certain that your passengers would make it round the loop. In this lesson, you will find out how to do such calculations. In this lesson, you will learn what is meant by centripetal acceleration, learn how to calculate centripetal acceleration, understand how the equation for centripetal acceleration is derived, and how radians are helpful in its derivation. You are at the fun fair. Click Play button to start the big wheel. When does the wheel have uniform circular motion? Answer: when its speed is constant. What quantities will be the same for the occupants of each car when the wheel is rotating with uniform circular motion? Answer: speed, radius of motion, kinetic energy, and magnitudes of vector quantities such as velocity, angular velocity, acceleration, and force. What quantities will be different for each car when the wheel has uniform circular motion? Answer: the vector quantities, velocity, angular velocity, acceleration, momentum, and force have different directions. Click Pause button to pause the motion at any point. With the motion paused, you can click on different cars to see how the motion is different from each one. Click Play button again, then click Reverse buttons to stop the wheel. Click Load Passengers and then Play button to try a different sort of motion. When is the motion circular but not uniform? Answer: when the wheel is speeding up or slowing down. Click Load Passengers button and then Play button to start the big wheel. Watch the two acceleration boxes as the wheel turns. How would you describe the direction of the tangential acceleration? Answer: along a tangent to the circle. Now watch the tangential acceleration and the velocity boxes. Do they have the same direction all the time? Answer: no. They have the same direction when speeding up and opposite direction when slowing down. Click Reverse button to stop the wheel and click Load Passengers button again so there are no passengers on the big wheel. Now click Play button to start the big wheel again. Look at the tangential acceleration box now. What happens to the tangential acceleration when the speed is constant? Answer: it is 0. Explore different motions of the wheel, remembering that you can click Pause and then click different cars for different viewpoints. How does the magnitude of the centripetal acceleration vector change compared to the velocity vector? Answer: the magnitude of the centripetal acceleration is greater when the magnitude of the velocity is greater. How does the direction of the centripetal acceleration vector change compared to the velocity vector? Answer: they are always perpendicular. The sentences below describe what is happening when circular motion is uniform. What are the missing words? Blank. Acceleration is equal to 0. Answer: tangential. The magnitude of blank acceleration depends on the magnitude of the blank. Answer: centripetal velocity. The direction of centripetal acceleration is blank to velocity. Answer: perpendicular. You have seen that the magnitude of the centripetal acceleration depends on the magnitude of the velocity. What is another name for the magnitude of velocity? Answer: speed. The equation in the small box gives the actual relationship between centripetal acceleration and speed. You will see how this equation is derived in activity 2. Use the sliders to set radius and speed to any values that you want. Now click play button to set the ball moving. Notice that the magnitude of the centripetal acceleration is calculated for you in the centripetal acceleration box on the right. Use the equation A equals v squared over r to check that you get the same value for centripetal acceleration. Click reverse button and use the sliders to try some other values of radius and speed. Why does the magnitude of the centripetal acceleration change so much? Answer: because it depends on the square of the speed. Speed is the distance traveled per second. You know that any distance on a circle equals r theta, where theta is the angle in radians and r is the radius. You have met omega, the angular velocity. What equation links the speed v and the angular velocity omega? Answer: v equals r omega. Then, what is the equation for centripetal acceleration in terms of omega and r instead of v and r? Answer: A equals omega squared r. This time, you can start the motion gradually. Use the sliders to set radius, speed and tangential acceleration and click play button to set the ball moving. You can click pause button to pause and reverse button to stop the motion. Read the sentences below. What are the missing words? An object starting from rest has a blank acceleration. This becomes blank when a blank speed is reached. Then the motion is blank circular motion. Answer: tangential, zero, constant, uniform. An object moving in a circle always has a blank acceleration. Answer: centripetal. The magnitude of the centripetal acceleration is equal to the square of the blank divided by the blank, or the square of the blank multiplied by the blank. Answer: speed or magnitude of velocity, radius, angular velocity, radius. Summary: if an object moving in a circle is speeding up, then it will have a tangential acceleration in the same direction as the velocity. If an object moving in a circle is slowing down, then it will have a tangential acceleration in the opposite direction to the velocity. The tangential acceleration is equal to zero when speed is constant. Circular motion is uniform. An object moving in a circle always has a centripetal acceleration. The centripetal acceleration is directed to the center of the circle and perpendicular to the velocity. The velocity v and angular velocity omega are related by v equals r omega, where r is the radius of the circle. The magnitude of the centripetal acceleration is given by a equals v squared over r. The magnitude of the centripetal acceleration in terms of angular velocity is given by a equals omega squared r.